How do we verify the identity listed above? Sine x plus y times sine x minus y equals sine squared x minus sine squared y. First, we expand the left side to be sine x cosine y plus sine y cosine x, all of that times sine x cosine y minus sine y cosine x. The next step, we multiply that out. Well, that's a plus b, a minus b, so we get the difference of two perfect squares, which is sine squared x cosine squared y minus sine squared y cosine squared x. Now we're going to do a little mathematical trick. We can always add 0 to an expression and end up with the same expression. So we're going to do sine squared x cosine squared y, and we'll put this term over here, minus sine squared y cosine squared x. And then what we're going to add in the middle is two terms that cancel each other out. So we're going to add plus sine squared x sine squared y minus sine squared x sine squared y. Because this term in the middle here added together is just 0, it doesn't change the expression. But it does allow us to then factor two different parts of this expression. So in this part, we're going to factor out a sine squared x. And that's going to give us cosine squared y plus sine squared y. And over here we're going to factor out minus sine squared y. So that's going to give us minus, minus sine squared y, which we're going to factor out. And that will give us sine squared x plus cosine squared x. But notice this term is just 1 by the Pythagorean identity, and this term is just 1. So what we're left with is sine squared x minus sine squared y. And that's exactly what we had on the other side. So we've proved the identity.